So cancer is one of the most pressing challenges in healthcare, if not the most important challenge in healthcare. You know, some good news that we've had recently is that the death rate has gone down about 1% per year over the last 20 years. Most recent year it went down 1.7%, which is really great news. A lot of that is because of, behavioral changes and so forth, smoking cessation and things like that, better lifestyles. But still the cancer rates are high enough to make it a pressing problem. So one of the truly exciting things in cancer is immunotherapy. Our immune system works with immune cells that travel through our body, basically looking for anything that doesn't belong. And that could be bacteria, viruses, even cancer. And when they find it, they eliminate it. And so what researchers are trying to do, and have been successful in some cases, is taking these immune cells and targeting them against cancer. Now, why wouldn't the immune cells just work on cancer? The problem is cancer is pretty devious, and it's built up ways to protect itself from the immune cells that are sent in to try to eradicate it. So researchers are working on ways to get around that. There's a couple of really exciting approaches I'd like to talk about. So one is Surface Oncology. They're doing work to alter the space around the outside of a tumor cell. This is known as the tumor microenvironment. And basically it is quite effective at turning off the immune process, the immune cells. So a lot of patients don't benefit from the therapies that they're on, especially in the long term. So by opening up this microenvironment, therapies can now get in, the immune cells can get in, and it's done through a broad attack on this microenvironment. And basically it's like neutralizing an enemy position before you send the troops in. So another exciting company is Therapeutics. They're in the business of advanced immune profiling of cancer patients. And so simply by recognizing neoantigens, they're better able to bring the fight to cancer. They're building molecular fingerprints that define how each patient's disease is unique. And like looking for needles in a haystack, their work will direct the therapeutic strategy for each individual patient. In essence, it's the right strategy for the right patient, guided by Google Maps at a molecular level. Finally, one other is a company called Unum. Their lead T-cell is called ACTR. ACTR, and as part of a novel therapy, ACTR cells are armed and then they're combined with specific antibodies to target the cancer cells. So these antibodies bind with the tumor cells and they basically label them for attack by the ACTR cells that come in and eradicate them. So it's like something like a heat-seeking missile, basically out of some Clancy novel.